And welcome back. Yes, I've had a bit of a rough week with my internet web radio. As you can see at the moment, it's not actually playing anything, not least because the socket at the back there isn't connected to the VS1053. Why? Well, the fact of the matter is I had huge problems with Wi-Fi and the ESP32 development board at the back there. How can I put this? Well, let me give you a quick snapshot of a log that I was taking to see what sort of messages were coming out. Now, this wasn't all the time, but when it did happen, that was it. Game over for a long time. So let's have a look at that log. JLCPCB offers custom PCBs with fast, reliable delivery. But today I want to talk about their SMT and PCB assembly from just $2. Let's have a look what that consists of, shall we? So as you can see here, the PCB and SMT assembly is available from $2. How do they do that? So normally there's a $7 setup fee, but in this case they're going to give you a voucher so you don't have to spend that money. Great, all you do is pay for your components. Simple. PCB SMT assembly from $2 from JLCPCB. Why don't you try them out now? So let's have a look at that log. So this is the log of the ESP32 development board that I was running with the web internet radio. So basically here you can see that we've connected to a station of some kind, and then suddenly we get a client not connected message, and I'm thinking, why on earth would my client suddenly become disconnected? How odd. So yeah, then I put some code in to say, look, if you disconnect, however rare that is, automatically reconnect. So as you can see here, it's trying to reconnect. It says I'm reconnecting to my SSID and I'm disconnected again. And then we go through this routine where it says I'm not associated, I'm disconnected, and then finally the absolute hammer drops on us and it says auth fail, which sort of sounds like, you know, you got your password wrong, except this is in my SPIFs file and it's only read once at startup, so we know that works. And I thought, my goodness, my Wi-Fi access point up there, which is separate from my router, is throwing a wobbly. So you disconnect it, reconnect it, start this up, and it all sort of springs back into life until the next time. And then we end up with page after page of all this, where you're disconnected, auth expire, we're trying to get some data, but no, then you end up with DNS failed, which happens intermittently but often, and I just think, what is going on? So anyway, I've fired up my router's built-in Wi-Fi, which I don't use because it's underneath my workbench here and the range is obviously going to be limited, so I use the one up there on the shelf to give a bit more range, even though I have actually got a repeater back in the lounge. It wouldn't even connect to that one. I'm going, is there something wrong with it? Have I specified a different password? Let me check my phone. No, the phone connects 100% every time. So of course, after pages and pages of this, I'm rebooting, as you can see, and basically hours can go by before this connects again. In fact, let me just skim through this log to see if I can find where it does connect again. Right, so here's a section then where I've obviously tried to change the station, thinking, is that going to help? It says, no, auth expire, and then suddenly it says, I've got an IP. In fact, it says it twice. I've got it there, and then I've got it again, so that's a bit odd in itself, isn't it? And then suddenly, after a DNS failed there, it decides, oh, all right, then I'll connect. Now, this is connecting without the metadata, as you can see there, just to make life easy for me, and it works for a little while and then goes wrong again. I think now I spent far too much time on the internet trying to figure what was going on out here, and the internet is full of this. ESP32s not connecting with a 202 auth fail or something similar, and the answer is always the same. Oh, try reconnecting, oh, try rebooting, oh, click your heels 3 times, turn around and it'll work. Absolute rubbish. Espressif really need to get up their game on this. I'm very, very annoyed because previously, if any of you remember my Home Alone project, and here on my desktop is a very early prototype that still works and I'll use for testing if I need to. This is using an ESP8266 module there, and then everything else sort of plugs in about it. Now ESP8266 has got Wi-Fi as well, far less memory of course. Did I have any problems with Wi-Fi whilst I was developing this and indeed testing it for months on end and then building another one and so forth and so on? Did I have any problems? Hands up, who thinks I had it? Exactly, I didn't have a second of problem. It certainly never disconnected, it never had an auth fail, it never had a DNS lookup problem, it just connected, and I'm connecting to Thingspeak often while I was testing every 5 minutes or so to upload some data to Thingspeak. If you don't know about Thingspeak, by the way, go and have a look at it. It's free for limited amounts of data, which is fine for me, and you can just put stuff up there and get lovely graphs and data, and you can read it back, which is what I do in JSON format. But anyway, that's sort of a bit of an aside. I never had a minute's trouble, and even more, I turn off the Wi-Fi on here and only turn it back on when I need to upload something. So I think it was every 20 minutes to begin with, I switch the Wi-Fi on, connect to the Wi-Fi in my mum's flat in Stuttgart, upload the data, switch it off again. And I do this however many 20 minutes there are in a day, and that's been running now for, it must be 2 years. And as I say, I built another one, I think it was last year September, so 2019, so that I could have 2 of these units in her apartment to detect movement, and it just works like a dream. Never did I have a problem with Wi-Fi. This, however, has been nothing but problems with the Wi-Fi. And Espressif do not have an answer. Now, admittedly, this revision of this board here is a revision 0 of the chip. Now, there is a Rev 1 and it was brought out pretty quickly, but of course the changelog, or the bug features that revision 1 is supposed to address, is not what we're seeing on here. It doesn't mention any of that, but who knows. Now, of course, the obvious thing would be to try a revision 1 version of the chip, and I do have one somewhere. It's probably scattered about here, is it? Oh, well, here's another one. I've got lots of these ESP32 stuff, but I thought, you know what? If there's something wrong with my router or Wi-Fi setup or something, rather than the ESP, let's try ESP8266, the same chip that I used in here. And what you're looking at here is, this is a Wemos Lolin NodeMCU V3. Yeah, I know, V3. It's really a V2 with a slightly improved USB port and a slight change to the pin so that you get VCC out on that pin there. Apart from that, it's a V2. Now, this has got 4 megabytes of memory, so plenty of room for both spiffs, well, little fs in this case, and the code. And the only thing it hasn't got a lot of is runtime memory. It's got about free at the moment, about 30 to 40k free. I think there's 80k-ish generally available, a lot of which is used up by Wi-Fi and Bluetooth and all the rest of it. But it's fine. It runs absolutely fine. And it's connected and it's linked up to my Wi-Fi now. Now, it's tuned, I hope, to radio 4. So let me just fiddle with a few knobs here and see what we, let's see what we get.
Onto the bug.
Right, that's radio 4. Okay, so I won't get clobbered by any kind of copyright strike. Well, I hope not. Yep, great. Anyway, it's connected and it's been running for hours and hours and hours, and I haven't had a single disconnect and certainly no DNS problems. So it is not my Wi-Fi setup. And just to prove the point, I connected that ESP8266 this morning to all 3 Wi-Fi networks that I have, including the extended repeater one way back in the lounge, and it goes, yeah, I've connected and here's your radio station. So ESP32, possibly revision 0, is a definite no-no, which is a shame because I've actually got on order an ESP32 W Rover, which is very similar to the one here, except it's got 8 megabytes, 4 megabytes sort of usable as PS RAM, which I was going to do a video on in the future, and I still might, because if I can have a 4 megabyte circular ring buffer on here, then that solves any stuttering at all, because 4 megabytes will give us a number of seconds of audio data that we can consume. And this is the biggest problem between your PC or an Amazon Echo unit or your phone or any device like that that's streaming data. They all have megabytes of data in which to buffer this stuff. So they buffer it quite a few seconds ahead and you consume it. And of course, if there's an interruption on the internet then for, half a second, it doesn't matter, because the buffer runs down very slowly and then they fill it back up again and all is well and you don't know anything's happened. Now, I've got a very quick mini video embedded coming up all about circular buffers. So if you're interested, keep watching. Otherwise, skip to the time that's going to be shown somewhere on the video about this point here. If you're not interested in how a circular buffer works, it's quite quick though. It's about 5-6 minutes-ish. And I'll see you the other side. So let's have a whirlwind tour of what a circular or ring buffer is. And basically, it's an area in memory. Here we have a 6-byte buffer, which isn't a lot, I know, but for the purposes of a demo, it's more than enough. And it's arranged, although this is a straight line, a circular or ring buffer is arranged as though the 6 here were connected all the way back round to here as it were a circle, so to speak, hence the circular buffer. So how does it work and what's the advantage? Well, the advantage is if we have a data recorder here, for example, that's recording temperature independently of a data logger logging here to an SD card or possibly displaying it on screen, let's see what would happen. Now, we have to know where the head of the buffer and the tail of the buffer are. The head is the new information, the tail is stuff that has yet to be processed by the data logger. Now, initially, they both point to the first available slot, but because the values are equal, that is, the head equals the tail, that means the buffer must be empty. Regardless of that there's sort of rubbish data in here, it means, as far as we're concerned, when the head equals the tail, the buffer itself is empty. So the data recorder comes along and says, great, where's the head of this buffer? Can I record into it? Well, it's empty because we know that head equals tail. So it goes, right, let's record my first temperature. And the first temperature might be 5 degrees centigrade. No, I don't know what that is in Fahrenheit, but you can have a look at a little translation table I've got there at the top of the screen. Right, so now it says I've got to move this head so it doesn't point to the first buffer anymore, it points to the next one. Now, the test that it must do at this point is say, is this next one going to be the tail? Because if it does, it means I can't do it. But no, it's not. Obviously, the head is now the same as the tail. So yes, we can point the head to the next one. Great, that's it. So we've got a single byte in the buffer. Okay, let's do this a couple more times and then see what happens with the data logger reading this buffer. Okay, so well and good. We've written a couple more bytes. The head is now pointed to the next available buffer. The tail hasn't moved. It's still back here because that's the first unprocessed byte that the data logger's got to read. So let's try that now. So the data logger says, right, where's my tail? Here, is it the same as the head, i.e. we've actually got an empty buffer? No, it's not. So I'm going to take that byte there, put it onto my SD card, and then move the tail up by 1. And there we are. Great. So we've copied the first data byte into our SD card, or put it on screen, or whatever we're doing with it, and everything's working fine. Okay, let's write a few more bytes here till we get to the end one and see what happens then. Okay, so we've just written our last value here, which is 11 degrees centigrade now, in byte position 6. And of course the data recorder says, well, I've got to increment the header count to the next available buffer position. Oh, I've run off the end. Well, if there's no more room here, it will go back to the beginning and say, right, I want to put it into buffer position 0 now. Can I do that? Is this the same as the tail? No, it's not. The tail is up here somewhere, so it doesn't care. So what we do, we take the head and we point it to the next available position, which is position 0. Now, as I say, there's rubbish data in here that's been long processed, but we don't care about that. All we know is that the head is now pointing to this position here, and the data recorder can write to it. Now, the data logger is still not doing anything at this point, because the data recorder is pretty quick and the temperature is going up. So it goes, right, I've got another value to write away now. I've got a 12 to write away. Where's the head? Well, the head is here. Can I write the value in here and increment the head to here? Oh, no, I can't. I'm within 1 byte of the tail, which means we have to keep this byte here empty. We sacrifice 1 byte so that we can tell where the head and the tail are, and this is considered to be a buffer full situation. We can't write the byte here, because if we were to write 12 here, we'd have to increment the head to point to this one, and as we know, if the head equals tail, it means you've got an empty buffer, which is most certainly not the case, so we can't do that. So what can we do with this 12? And the answer is absolutely nothing. The buffer is full, and it just has to wait until the buffer becomes empty. So if the data logger now says, right, I want my next data byte, please, where's the tail gone? The tail is at number 6, and it's not the same as the head, so it's therefore not an empty buffer situation. There's obviously data to be processed. Great, I'm taking this byte here, and I'm moving it to my SD card, and then I'm going to increment the tail to the next position, just like that. Now the data logger can continue reading these and moving the tail up by 1 position, which gives plenty of room then for the data recorder to continue writing bytes behind it. But as I say, there's always got to be 1 byte we sacrifice that's the flag, if you like, to show us when the buffer's full. The alternative way of saying when it's full is to actually have another variable. Yeah, so we can have a Boolean full equals false, and then change that to true and false depending on what here. But in my mind that is ugly, because we're still using a byte of data here. And now we've got something that's not part of this buffer trying to tell us what the state is. I don't like that one bit, and it's not the way I've done it. So that basically is how a circular buffer works. This will continue to come up here. Let's read all the remaining bytes to here, and then see what the data logger does with any remaining data. So we're now in the position where the data logger has read all these remaining bytes. It's pointed the tail up to here, and it goes, right, I want to read this one too. So it crosses that one out. It reads that one and puts it into the SD card. And it says, now I've got to move the tail to, oh, I'll run off the end. Well, it does exactly the same as what the data recorder did. And it says, right, I really now have got to point this back at the beginning all the way over here. And it doesn't care whether this value here is being pointed to by the head or not. Let's see why. So here we are. It's read this last value, written it to the SD card, pointed the tail of the buffer back to here. But now, of course, we're in the same position as what we were just a little while ago. The head equals the tail, which means this buffer is empty. Nothing has been written to it that we need to process. And even though there's sort of rubbish old data in here, all that has been processed, as we can see by this here. And that is basically the principle of a circular or ring buffer. We just keep moving around, keeping track of whether the head equals the tail, which means it's an empty buffer, or whether the head is within 1 byte of the tail, in which case we cannot write anymore. And we sacrifice 1 byte out of this buffer bytes to say, no, can't do it, sorry, just have to wait. Cool, okay, so that's what a circular buffer is, but how does that actually apply then? Not for temperature recording devices and data logging things, but as we are here, we're streaming data from the internet. That's quite a different thing, isn't it? We're not just having a byte or two coming down, we're having lots of data available to us, and the VS1053 that we're using in this MP3 web radio that requires 32 bytes of data every 2 milliseconds at a 128K kilobits streaming data rate. Okay, so that's a fair bit of data, isn't it? It's a pity in some ways that the VS1053 doesn't have some sort of built-in buffering on board, apart from those 32 bytes, which could be as little as 1 millisecond if you're going to up the streaming rate, but whatever, it's small. So how does this all tie in then with internet streaming? So streaming data from the internet, so it's not a data recorder anymore now, this is an internet radio station. That is putting stuff into the buffer at a great rate of knots. And the data reader, so it's not a logger, this is a player, an MP3 player or data streaming player, is reading buffer data at a great rate of knots as well. But you can always put stuff in the buffer quicker than you can read it normally. So this buffer has normally got more bytes in it than this can handle. So this becomes full. And this will have to stop writing bytes into the buffer until some has been read out. That's the situation you want to be in with a full buffer, so that this has got some wriggle room, if you like. Because what happens if the data recorder version of the streaming data doesn't write data in here quickly enough? Well, the data logger will read the data, and we'll get to this situation where they're both pointing to the same byte, which means we've got an empty buffer. And the player cannot read any more data. What happens? Well, your music stops and you'll get a jitter or a silence. Now, it might only last for a millisecond, or it could last for several seconds. Whichever one it is, though, you'll hear it, and it will sound quite irritating, believe me. How do we overcome this problem then, where the buffer can become full or there's no data? Well, the best thing to do is have a huge buffer. The more bytes you can cram in here overcomes the problem when there's an interruption on the data stream. And ditto, a huge buffer here means that the data player can just happily read bytes out of it however many it needs at a time, in our case 32, without even worrying about whether there's any data in here, because there always will be. The problem is we haven't got that much memory on our microcontroller. So that's where we are then with the streaming radio. Now, if I can get the W Rover one working, because maybe it has a higher revision ESP32 chip on it, great. I'll sort of forgive Espressif for wasting a good amount of my time trying to get this working. In the meantime, I'm carrying on with the ESP8266. As I say, this is a NodeMCU, 4 megabytes of data, or well, flash memory, and there are lots of ESP8266s with that sort of configuration, and you don't have to use this exact one. I'm slightly worried I'm going to be running out of pins because I haven't got a screen connected to this one yet. Okay, we're on here. Yes, we're sharing at least 6 pins with the SPI bus, but there's still quite a few more pins that should be connected, and I don't think I'm going to have enough on here. But if not, I'll have to use a different sort of screen, I guess, but we'll come to that when I know exactly what's happening on the ESP32 front. Now, if we just look at the log of that Radio 4 that's running at the moment. Now, let me call up CoolTerm. I'm using CoolTerm again, which incidentally has improved quite a bit over the last few months. Lots of features and things. I don't know whether it's a result of my email to him a few months back or whether he's just doing it. I don't know. I'll send him another one. Yeah, he probably hates me by now. Let's have a look at CoolTerm's monitor. Here it is. So this is where I rebooted the ESP8266. And as you can see here, it's going on to the Wi-Fi straight away. Which one are we going on to? Greypuss. That's the one up in the corner there. But I've had it, as I say, onto the one under the workbench and the extension one over there. So it connects straight away, connects to BBC Radio 4. There it is, look, BBC Radio 4. Have you noticed, incidentally, even if you request no metadata, you still get the headers with the IC data in it, apart from the metadata interval. You don't get that because there is no interval, it's a continuous stream. However, here I've said, yes, I do want it with metadata. Now that caused a lot of problems with the ESP32. I don't know why. But on this one, as you can see here, it says, yeah, I've done it. I've got free memory of only 26K. That's a bit different to the 200K or something I have on the ESP32. But after that, we're just getting some debugging messages. Basically, I'm saying if I don't write a full 32 or is it 100 bytes to the circular buffer, I put it out. And here's the buffering, the buffer level. And as you can see, it's pretty stable at in the high 90s, isn't it? 97, 98. And that's where we are at this very second that it's playing. Now, although there is still some of that background noise, probably caused by all the digital noise on here, it's far, far less than on the ESP32. Now, I know the wiring on the ESP32 is a little bit, yeah, there's a lot of wires there, isn't there? But this thing just, I don't know, it just seems to work better. Is it a more mature product? Is the ESP32 a little bit flaky at the end of the day? I don't know. I'd really like it. Those people out there who have used an ESP32 for connecting to Wi-Fi, have you had any trouble? And what revision of the chip have you got? You can tell because every time you upload something to it, whether it's in the Arduino IDE or in this case Platform IO, it will tell you exactly what it's found. Okay, so what I did, I created a new project under Platform IO, to say ESP8266 Internet Radio, that one there, and basically copied the code across and made changes. Now there were some changes. If you look at the main one here, the includes, which are right at the top. For a start, you have to use ESP826 Wi-Fi, so it's a different library. Now, whether it's the library that's more reliable and does the right stuff, or whether it's the hardware, I cannot possibly say. All I know is the internet is buzzing with problems about that ESP32 Wi-Fi, and I don't know which one it is, hardware, software, combination of the both maybe. I'll wait for your comments on that one. Everything else seems to work as it did before. Oh yes, we haven't got preferences on this one. We have to use EEPROM directly, which if I have to stick with the ESP8266, I'll be taking that off and using SPIFs, or rather little FS. That's that one there. And the thing about the little fs is you do write it in lowercase, so capital L, small lowercase I-T-T-L-E, capital F-S. Yeah, I know, it was littered with errors, this program, because I have to use capitals for the ESP32. I wish somebody would join the dots up and just make it the same, but there we are. Oh yeah, and the pinout, of course, for the VS1053 is a bit different as well. Now, talking of pinouts, I'll put the pinout for that particular one I've got in my GitHub, and it looks like this. So this is the ESP8266 Wemos Lolin NodeMCU. Yeah, V3 it says on mine, but it's just made up. It's a V2 really. The V3 basically has a slightly better, it says, USB port, and up here, instead of it being RSV, it's something like USB power out or something like that. But as you can see, we have to use these pins here for the SPI. We cannot use these because these are for the internal SPI flash memory of this chip. I say internal. If you were to take this cover off, the ESP8266 will be a separate chip, and the flash memory will be a separate chip to that, all joined up via SPI wires. But we can't use any of those apparently. So that worries me, because the VS1053 uses D0, 1, 3 and 4 I think, which gives me one more that I'm currently using to change the station. And that's sort of, well, I'm sort of run out now. I can probably use A0 maybe as a digital pin as well, but I don't know where that screen's going to plug in. It probably won't. So yeah, we'll have to think about that, and perhaps use a different screen, an SPI screen that doesn't require 16 wires or whatever it is on there. I don't know. Anyway, that's just bring you up to speed really. So a final word about circular buffers then. At the moment on this ESP8266, I've got a 10,000 byte buffer, which you go, whoa, 10,000 bytes of your SRAM. Yes, but let's have a look how long that actually lasts for, shall we? Let me bring up the calculator. We've got 10,000 bytes. Now, we give those bytes to the VS1053 MP3 decoder in 32 byte chunks. So divide that by 32. That equals 312.5. And each one of those is for 2 milliseconds approximately. So multiply that by 2. And you can see that we have 625 milliseconds worth of buffering, which is just over half a second. Now, even my Amazon Echo occasionally stutters and stops, and certainly the internet does occasionally, not very often, and they've got megabytes of buffering. But with just 0.625 of a second's worth, I think the ESP8266 will exhibit the occasional stuttering and gaps. Now, if my ESP32 Rover version with its 4 megabytes of PS RAM can be used for that buffering, which I sincerely hope so, let's see how long that would last for. So we're going to say, let's assume we use all 4 megabytes. So 4, 1, 2, 3, 1, 2, 3. Right, divide that by 32. That gives us 125 times 2. So it's 250,000 milliseconds. So let's divide that by 1,000. 250 seconds worth of buffering, which is a ridiculous amount. We wouldn't need that much. Would we? 250 seconds. That's like 3 minutes or something. What we could probably do with is something like 10 seconds of buffering. So I'll be very interested when they come. In fact, I've got 2 different ones on order, just to see how they both work. One's got a lot of documentation on the internet. The makers of it have got lots of information, so I thought, yeah, I'll use that. And they're a small sort of startup place, so good to support people like that. And the other one's just a standard. I think it's from Banggood. Yeah, Banggood, I'm buying it. So that'll be for a future video, how we use this PS RAM as standard SRAM. I say standard, and how well it works, or whether that crashes every 2 minutes as well. I wouldn't put it past them. Right, so that's it for this week. As I say, a little bit of frustration on the ESP32 front with that connection to the Wi-Fi, but I'm hoping I can get around that if I use a different version of the chip, because if I do use a different version of the chip, revision 1, and it still does that, then I wouldn't know where to go. And as I say, because the internet is full of people reporting these sort of errors and Espressif not really knuckling down and addressing that issue, it would be frustrating for everybody to build this and then have, you know, stops and starts and disconnections. I mean, it's bad enough that the stream itself occasionally has these little interruptions from the actual server, let alone the actual unit here disconnecting at whim. It's just not a pleasant experience. In which case, if that does happen, I'll be concentrating on this. And of course, there are quite a few questions on the internet saying, how can we increase the SRAM on here? There's a few suggestions. Exactly how viable they are, I don't know. I haven't really looked at them in detail, but you never know. You never know. Okay, I'll look very much for your comments about the ESP32 and your experiences of it, if any. And yeah, maybe this time next week I'll have some more positive news, and hopefully this will still be intact and not taken apart and thrown away in the bin, because that's the way I feel at the minute. Yeah, I know, it's terrible, isn't it? Okay, thanks very much for watching. Don't forget your comments, don't forget to do a like, all that other stuff. Thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.